Welcome back. In the last video, we built a small math toolbox in SCL. We calculated the speed conversions, torque, energy use, and we even set limits on values. That was all about getting numbers. Today, we will use those numbers to actually make decisions in the PLC. And the tool for that is the if statement, along with else and ELSIF. If math is the brain of the PLC, if and else is the voice that says, okay, here's what we are going to do. We already have most of what we need in the parameters data block from the last two videos. If you haven't watched the previous videos, please click on the link above and watch those videos. They are about the math operations in SCL. For this video, let's add two more variables today. The first one is alarm text. This one is a string and it's to store a short alarm message. The next one is motor command and it's a Boolean signal to start or stop the motor automatically. Everything else, the speed, torque, load, energy, we already have them here. Okay, let's create another function for today's tutorial. I call it if statement. Alright, before we jump into coding, let's pause and look at this in the simplest way possible. Okay, I'm going to write it out big. If condition, then action. That's it. It's like asking a really simple question. For example, if it's raining, then what's the action? You need an umbrella, right? So if it's raining, then take an umbrella. Super basic, right? But this exact structure is what we're coding into the PLC. Here, the raining is condition and take an umbrella is an action. But what if it's not raining? Then we have else. And we define actions for that. So here, if it's not raining, you can wear your sunglasses. So here, wearing the sunglasses is the action. Now if we add more options, we bring in ELSIF. So I'll sketch it out too. So you see the flow here, one condition at a time, top to bottom. The PLC checks the first if it's not true, it goes to the next else if none of them are true, it falls back to else. Okay, now let's start with the simplest possible if statement. Turning on an alarm if the motor load exceeds 90%. So here we assign code 101 to alarm code and we want to have a message to be shown to the operator, and that is motor load high. Right, so this is our statement. Let me add a comment here. This one is example 1, simple if. Okay. So here to test the code, I will need to add this function in our OB1. Let me create a new network. Let's name it if statement. And let me drag and drop the function here. There we go. We don't need this network here, so beautiful. So I'll download the code. Oh, let me compile first and download it to the PLC. Beautiful. Let's go online. And monitor the code here. Okay. So here to test the code, we can change the motor load percentage here. So right now, the condition is false. I'll set it to 90% and you see the condition is true. If the condition is true, the PLC execute those two lines, set the alarm code and message. And if it's false, it skips them completely. And as you can see, we have those values here. This reads exactly like how you would describe it in a meeting. If motor load is greater than 90%, set high load alarm. Okay, now what if we want the PLC to take one action? If the load is high and a different one if it's not. That's where else comes in. So now I will add the motor command is also here. So if the motor load is greater than 90%, I want to stop the motor. Everything else is okay. I want to add else here and assign the motor command true, so then the motor can run. The alarm code here can be 0, and we don't have any value for the alarm text. There's no alarm. Okay, save the project, compile and download to the PLC. Now let's test the code. So I monitor the function. Let me also monitor the values in the data block here. So as you can see, the motor command is true and there is no alarm. And of course there is no alarm text because the motor load is not greater than 90%. But we add an alarm text here. Let's say no error. So you can see it better. Let me download. Yeah, there we go. So there is no alarm, so no error here. So if the load is too high, the PLC stops the motor and gives an alarm, as you can see here. And if the load is fine, it clears the alarm and runs the motor. This is the first step toward automatic protection logic. Now let's go one step further. Different alarms for different levels. Instead of stacking a bunch of ifs, we can use ELSIF here. So let me make it a bit more clear. So let's say if the motor load percentage is greater than 95%, the alarm code is 103. For the alarm text, we can have motor load, overload, and critical. Of course, we're going to stop the motor in this condition. Now we use ELSIF here. So same pattern. as before. Here we're gonna say if the motor load is greater than 90%, we're gonna have alarm code equal to 102. For alarm text, we can say motor load high. We can keep running the motor. That's okay. So we add another ELSIF and we define a new condition. If motor load percentage is greater than 80%, let me just copy and paste the actions here. So here the alarm code can be 101, for example, and the motor load warning for the alarm text. Here is also motor can keep running. And the last one, if none of the condition above is true, we want to have alarm code equal to 0, so there is no error. Here we also have no error text, and the motor of course can run because there is no error at fault. Let me compile, no error, beautiful. Save the project and download to the PLC. Let me monitor the code. Okay, beautiful. Okay. So to test, I set the motor load a value greater than 95 to go from top to bottom. Let me just place it here. This way the PLC checks the first condition. If it's not true, it moves to the next and so on. The first match wins and the rest are skipped. This way is a really clean way to handle multiple threshold without making a mess of your logic. So here, as you can see, the first condition is true and you can see the outputs. Now let's test the second condition. There we go. You can see the outputs is exactly what we set for them. This is the alarm code and motor command and alarm text. Now let's test the next one. Here the third condition is true, and as you can see the outputs obviously exactly same as what we set for them. And lastly, if none of the conditions are true, it will move to the else actions. Okay, beautiful, exactly what we want to have here. Okay, before we go back to TR Portal, let's also look at something really common, a nested if. So here, if we say temperature is greater than 90, then we want to also check if the fan is running or not. If the fan is off, we want to have an alarm to say alarm is high temperature and fan off. That's a text that we want to show to the operator. And else, meaning that if the fan is not running, so we have the high temperature alarm, and the difference is this time fan is running. So that's the nested if. And else, if the temperature is not greater than 90, then there is no error. That's nesting. Basically, one decision inside another. That's a clean way to handle multiple layers without writing a giant ELSIF chain. Just remember, 1 or 2 levels of nesting is fine, but don't go too deep or the logic becomes a maze. Okay, so sometimes you only want to check something if another thing is already true. That's a nested if, as we discussed. For this example, we want to only check for high torque if the motor is running. So the first condition is the motor command equal to true, and the second one is the torque condition. If that's greater than 8, so in that case we want to generate this alarm code and the alarm text. Let's say torque limit exceeded. Beautiful. So we close this if loop and if. Also we close the main if loop. Okay. Let's save the project, compile and download. This is great for building conditional logic without unnecessary checks. So here we can test. As you see, the alarm text and alarm code here, they have their own last valid values. If I assign the motor command to true, we can see that the alarm text and alarm code will be updated. There we go. Beautiful. So alarm code is 201 and the alarm text is torque limit exceeded. So now you know how to make the PLC react to numbers. If, else, and ELSIF let you write logic that's easy to read and maintain. In the next video, we'll handle repetitive tasks with for loops so we can scan through multiple sensors or devices without writing the same code 10 times. That's where SCL really starts to shine for large systems. If you like this video, please give it a thumbs up and subscribe for new videos. Thanks for watching.